including the Roadster, Model S, and Model X, have used some variation of the venerable three-phase AC induction motor. Nikola's electric motor was attached to a permanent position three-phase AC power outlet for many years after it was created. In the 1960s, digital electronics from Silicon Valley helped to finally release the induction motor from its constraints. One of the first portable inverters, which converts the direct current, or DC, in an electric car's battery into the alternating current, or AC, needed by an induction motor was created by unconventional engineer Alan Cocconi in the early 1990s. The inverter-slash-motor combination was initially used in an EV that would later become the GM EV1. Later, Cocconi installed an improved version of that powertrain into the T0 sports car, which was later discovered by Tesla Motors co-founder Martin Eberhard and Mark Tarpenning, and a little later by Elon Musk. For the Roadster, Tesla would ultimately license the T0's powertrain technology. Those historical connections indicate the main justification for Tesla Motors' decision to deploy an induction motor in its first manufacturing vehicle, albeit with many improvements. The induction motor's lack of a need for permanent magnets is one of its most attractive features. Permanent magnets, of the rare earth variety, which are notorious for characteristics like high initial cost, the tendency to demagnetize or shatter, sourcing challenges, and price unpredictably, are typical of sufficient power to spin up the motor of an EV. However, the induction motor without PM could now be used in the transportation industry thanks to the transistor. With the help of transistors with obscure names like complementary metal oxide field effect transistor, or MOSFET, and later insulated gate bipolar transistor, the induction motor uses electromagnets, coils of wire wrapped around a ferrous metal core, which can be turned on and off, or switched, numerous times per second, or IGBT. Of course, the induction motor is a fantastic device, but it isn't flawless. Tesla's design makes use of a pricey and challenging-to-cast pure copper rotor. The rotor also has a tendency to heat up and possibly overheat because of how induction motors work. Heat is a form of energy loss, or I2R loss, and it matters in an electric vehicle. The door has always been open to a more effective and less expensive solution because induction motors are less efficient at low speeds than some other designs. Almost all of Tesla's vehicles, including the Roadster, Model S, and Model X, have used some variation of the venerable three-phase AC induction motor. Nikola's electric motor was attached to a permanent position three-phase AC power outlet for many years after it was created. In place of an internal combustion engine, Tesla's automobiles, sometimes referred to as EVs, use an electric motor. They run in the internal electric motor on a sizable traction battery pack. Nidec Corp., the leading manufacturer of motors for everything from hard drives to power plants, Nidec Corp., is making a wager that it can produce a crucial part of Tesla Inc.'s electric vehicles more affordably and effectively than anyone else, potentially including the company's CEO, Elon Musk. Teslas have single-speed transmissions with no gears and electric motors with two moving elements. According to the business, the drivetrain contains 17 moving components as opposed to 200 in a typical internal combustion drivetrain. Almost no maintenance is required for the Tesla system. Tesla vehicles don't need standard maintenance like oil changes, fuel filters, spark plug replacements, or pollution tests like gasoline vehicles do, because regenerative braking transfers energy to the battery, considerably minimizing brake wear. Even brake pad changes are uncommon in electric cars. How potent is a Tesla's engine? Since they are electric vehicles, they lack engines. Their motors can produce 825 horsepower and 960 pound-foot of torque when their front and rear motors are combined. There are no engines in Tesla automobiles. They utilize electric motors with rechargeable batteries as opposed to other forms of propulsion. Teslas with rear-wheel drive, or RWD, have the motor just above the rear axle. The front motor is mounted between the front two wheels of all-wheel drive, or AWD, vehicles. Unfortunately, the Model 3 does not use an induction motor for power. Wow! We are curious as to why Tesla chose to name his invention the induction motor. What is happening? What motor did the business utilize at its place? However, Tesla is silent. Okay, they are speaking briefly. When Tesla's chief technology officer, J.B. Straubel, assured us that the Model 3 would include a new motor technology, he forewarned us of impending changes. We also received a heads up when, in late 2017, an EPA document came to light revealing the Model 3's use of a permanent magnet motor. Wow and wow. This was verified earlier this year when Tesla's chief motor designer, Konstantinos Laskaris, was quoted in a charged article describing the new motor in the following manner. So as you know, our Model 3 has a permanent magnet machine now. This is due to the permanent magnet machine's superior ability to satisfy our cost minimization function while also being ideal for the range and performance aim. Yeah. Therefore, we can say with certainty that the Model 3 uses a permanent magnet motor rather than an induction motor. The motor type was originally listed in the EPA document as AC3 phase permanent magnet, replete with a misspelling. As a reference, the Chevy Bolt EV uses a 3-phase permanent magnet motor. But I think this is all we can claim to know. It's conjecture from this point forward. Guesswork. Where the jigsaw puzzle parts are starting to come together properly, though, is still speculation. Let's try to figure out if the Model 3 is indeed using the same kind of motor as, say, the Bolt, as it first appeared to be. The master of auto teardowns, Engineerix, in February. Engineerix published a collection of intriguing films delving into the functionality of the Model 3. He examines the car's underside in an entry headed The Dark Side, and begins listing its parts and systems as if he were reading from a script. Really thorough information that, as far as I'm aware, has never been made public. The man appears to be extremely knowledgeable. In the comments area of the video, I spoke with Engineerix, who revealed that the vehicle features a switched reluctance motor employing permanent magnets. Tesla refers to it as a PMSRM, or a permanent magnet switched reluctance motor, continued Engineerix. Tesla succeeded, despite being a new type and extremely difficult to get correctly. Tesla initially employed induction, or asynchronous, electric motors, by the way, invented by Nikola Tesla. The internal permanent magnet synchronous reluctance motor, also known as the PMI-SynRM permanent magnet assisted synchronous reluctance motor, was utilized by the manufacturer in Model 3. It's a type that, in general, combines an internal permanent magnet motor with a synchronous reluctance motor rotor to produce a quality that is more sought after in an EV application: high efficiency at low and high speeds. Although it wasn't the first to employ this type of motor, Tesla is regarded as one of the best, simply because of the high efficiency and range of Tesla cars. The segmented magnets are a unique invention by Tesla, 4 parts instead of the more typical single solid magnet. Eddy currents are lessened, and the danger of magnets overheating is decreased, claims Learn Engineering. We must first refresh our recollections of how Tesla's traditional 3-phase AC induction motor functions in order to fully comprehend what makes the reluctance motor worthy of the Model 3 design, which I wrote about in some detail here. Just take note of this one fact about the motor, even if you're not a motorhead. The term induction refers to the fact that, instead of using expensive permanent magnets on the rotor, a powerful magnetic field produced by the stator of the motor actually induces an antagonistic magnetic field on the extremely conductive copper rotor. We also know that when 2 magnetic fields that are in opposition to one another interact, they pull in the same direction. If you move an opposite polarity magnet near a magnet in your hand that is on the kitchen table, the magnet in your hand will pull the other magnet in that direction. The ludicrous Model S P100D takes off like a bat out of hell when 2 opposing magnetic fields created inside the motor interact. Ganji Lithium Co., the largest manufacturer of battery-grade lithium in the world, Ganfeng Lithium Co., has a supply agreement with Tesla. A 3-year supply agreement with Tesla has been struck by China's Ganfeng Lithium Co. Ltd. and its subsidiary GFL International Co. Ltd., according to a filing on the Shenzhen Stock Exchange today. Longer ranges and greater power are produced by the new batteries in Teslas because they fit more cells into the same volume as they did in earlier models. The speedier car is a result of the higher energy density given.